it was 23 inches long. And now, if we think about the miniaturization of cell phones, we go from 1973 to 2015, and the compute power in these cell phones is remarkable. And what it has done is it has now made something, we talked earlier today about the democratization of health, but this is the type of technology that everyone has. 90% of Americans own a cell phone, 64% of Americans own a smartphone, and 73% of American teens own a smartphone. So this is going to be ubiquitous technology. What it means is patients can manage their health, it's improving diagnostics, health records can be maintained, and then there's obviously the nutrition and wellness space. But I think what's most important is that with these cell phones, we've really shifted healthcare and opened up this platform and potential to link a lot of devices in the way you see here. And this is just a list of different companies that are working now in movement disorders, cardiovascular space, sleep disorder, temperatures. We heard earlier about monitoring asthma and respiratory abnormalities, all the way down to thinking a bit about how to label pills, so proteosis labeling pills, thinking about ingestion. And so as we have these devices that can integrate all the information, we're now going to spend some time today talking about ways of actually creating sensors and creating smart sensors. And so this is a picture of just one of the continuous medical monitors, and I think there's been a huge spectrum. There's certainly a large number of technologies in the health and wellness space. And where people are now leaning really into is creating medical grade technologies, so that when a signal is available, it can be actionable. What is very helpful, as we heard today, examples to get a medical output that then we can say this is an SVT, this is atrial fibrillation, this is ventricular tachycardia. But as a physician, I need to know that I can trust that output. And so leaning into medical grade devices, I think, is personally the right way to go. It's something that we are doing philosophically and feel that we need to work closely with the FDA. Now the second definition, so this I think is a bit standard, this is where we are today. But the second definition of mobile speaks to able to move or be moved freely or easily. So how small can we get these sensors, and can we actually get to a point of passive sensing? And this is where I think examples are very helpful. And I know yesterday there was a discussion about diabetes management. We know that there are over 300 million people around the world who have diabetes. The standard of care for someone with diabetes is to check finger sticks invasively. I remember my grandfather was very meticulous. He would check his blood sugar 4 times a day. He kept a nice notebook. He would bring it into the doctor. It's very hard to integrate, many values of such. But this is the standard way that people were monitoring diabetes. And what I'm showing you here, this is really just more of an example, but this is a contact lens. And this is a contact lens that can continuously monitor glucose. And the way it works is there's an incredibly small sensor. There is the entire wireless IC that is embedded between the silicon contact lenses. And what it does is it's good for people who need corrective lenses. So we partnered with Alcon so that obviously it's good for people to be able to see. But the other thing is that the compute power in this is beyond our early computers. I don't know if anyone, my first computer was a Commodore 64. This is way more powerful than my Commodore 64. But as it turns out, the compute power is just an example of ways to create a sensor, to integrate this information, and to hopefully give real-time feedback. So there's a very interesting survey when you ask patients, what do you think is the most important medicine that you take? And as a cardiologist, I thought, oh, this is going to be maybe statins. Statins save lives, they're wonderful medications. That was going to be my vote. There's a mortality benefit. But in fact, what patients like most, and I don't know if there are any guesses in the audience. Does anyone have a medicine you really love? Aspirin. So aspirin was number 2. The number 1 medicine was Imodium, because it works really quickly, and it works really fast, and the feedback loop is closed. Imodium, as it turns out, is at least in the survey, the most popular medication in the United States. So the reason why, though, is there's an immediate feedback loop. And so statins don't make you feel better. They don't make you happier. You know, in the long run, they may save your life, but they're not as popular as Imodium. And so if we think about these miniaturization of sensors, and then we think about using this example of diabetes, where the sensors are now small enough, we're working on a patch where we typically think about continuous glucose monitors as something that patients with type 1 diabetes would use. But as these patches become the size of a Band-Aid, and as they become incredibly cheap, So we're talking about technologies that are going to be pennies a day, and I think that was a really important theme. How can we make products that are scalable and not restricted either to certain disease types or certain types of patients who have access? And so if you were to have a continuous glucose monitor that was pennies a day, that you could have real-time feedback. Yeah, people say, well, I manage patients with type 2 diabetes, am I going to titrate their metformin on a daily basis? Absolutely not. But what it might do is if I'm a patient with diabetes or if I'm someone who's monitoring my glucose, if I eat a donut and immediately my patch tells me that my glucose spikes, I'm getting that immediate feedback. I'm getting that Imodium equivalent of diabetes care. And so it's this behavior modification, this real-time feedback that I think is going to help us rethink a little bit about how to engage with people, engage really with users. And this is a place where I think the tech world has thought a lot about, and I think it was really nicely articulated about the strengths of the tech world and how we as healthcare providers need to really be paying attention. Then when we think about even smaller, so now I've shown you, we've talked about phones, we've talked about watches, we've talked about patches. This is a little sci-fi, so I always preface, I think we're sometimes accused of talking about moonshots, and so I always preface where things are a little further off, but I want us to at least be thinking about this concept of nanodiagnostics. And the idea that, so it's not something now that you would even need to wear, this is something you might be able to take a pill, it would circulate, and you would be able to pick up, for example, on circulating tumor cells. And so we have a whole team of scientists, and as do other groups, working on this particular problem. Again, this is not something that's going to be available tomorrow, but I think these are the directions that we're thinking about as we're getting smaller and smaller and the sensors are shrinking. And it gets us to a point where we may not even need to be wearing these sensors. And so maybe this is an example of when we think about smoke detectors, right? Everyone has a smoke detector. You have to have a smoke detector. You can't not. But the idea is to pick up on these smoke signals before it becomes a problem. And it's not that we're all wearing and walking around with these smoke detectors. And so what is the future of passive sensing? And this is something that Eric and I have talked a lot about and have talked to groups that are now thinking about not the need to have something on your body, but being able to passively sense, for example, when a patient, this is a patient with sinus rhythm, who then developed ventricular tachycardia, which can be a notoriously fatal rhythm. What if you were sitting there? We know that sudden cardiac death is a big problem worldwide. So if someone is sitting there, their heart goes into this arrhythmia, you automatically have that sense, the phone calls 911, and healthcare is delivered to your home. This is an issue that we grapple with greatly in cardiology. We don't have a good solution right now, but this, at least conceptually, is where people are going. I think in the neurologic space, there's similar types of initiatives trying to think about ways to passively sense if someone's having a seizure, and again, having the same feedback loop. Because if we can instrument everyday living, and if we can come up with this idea that sensing is available to us, it brings down the bar. So I think that there's going to be a role for wearables, definitely, but people have to remember that. And this is something where it's ubiquitous, or could be ubiquitous, and could be very easy. Another place is thinking about allergen detection. There are groups trying to think, we know that peanut allergies are quite common now. There's some very interesting science to try to figure out why that's the case. But what if you had a detection system where it said there's an allergen here for kids, for example, you're stepping into an area that's going to be very problematic. And I think I certainly have taken care of my patients who get intubated. It's a very challenging thing. So could you actually predict this from happening? So that was a little bit on this idea of mobile, and I hope we kind of are thinking about that continuum of really bringing down the scale.